Hi, in this video, let us find the absolute extreme values and where they occur for the following graphs. Suppose if we take this graph, here there is no absolute maximum and absolute minimum because actually we can say this is the absolute maximum if it is included, but these points are excluded. So we cannot say what is the absolute maximum and what is the absolute minimum. If these points are included, then we can say, but these are excluded. So there is no absolute extreme values. But local minimum at minus 1 comma 0, that is at x equal to minus 1, y is 0. This is the local minimum. That is, this is the minimum value of the y for all these points, for these all these neighboring points. This is the minimum value. That is the local minimum at x equal to minus 1 and y is 0. And it is the local maximum, that is at x equal to 1 and y is 0. These are the local maximum and local minimum values, but there are no extreme values. Those are the no absolute maximum and no absolute minimum for this graph. Now let us see this graph. These are the closed intervals. These points are included. So these 2 points are absolute minimums. That is the absolute minima at x equal to minus 2 and y is 0. And also another absolute minimum, that is at x equal to 2, y is 0. That is a 2 comma 0. And it is the absolute maximum, that is at x equal to 0 and y is 2. Next, for this graph, here maximum at x equal to 0 and that is y is 5. And there is no minimum since the end point 2 comma 0 is excluded from the graph. If it is included, it will be a absolute minimum, but it is excluded. So there is no minimum, there is no absolute minimum. Now let us see this graph. Here these points are the local maximum, that is minus 3 at x equal to minus 3, y is 0. That is the local maximum. It means this is the maximum value for these neighboring points. So this is the local maximum at minus 3 comma 0. And local minimum, that is at x equal to 2, y is 0. For all these neighboring points, this is the minimum value, that is at x equal to 2, y is 0. And absolute maximum, that absolute maximum at x equal to 1 and y is 2. Here minus 1, 0 comma minus 1, that is the absolute minimum, that x equal to 0 and y is minus 1. Let us see another example, that is match the tables with the graphs. There are 4 tables and there are 4 graphs. We have to match these tables with the graphs. First, let us see this graph, that is table, 11th table, that at x equal to a, f dash of a is 0 and f dash of b 0, f dash of c is the 5. It means that f dash of a equal to 0 means the tangent at x equal to a, that is a horizontal, that may be local maximum or local minimum. Similarly at b, and that f dash of c is 5, that is a positive number, that is greater than 0, means that graph must be increasing with a fairly steep positive slope. Let us verify such graph, that is horizontal tangents are local maximum or local minimum at a and b, and this is the only positive slope for the remaining from the remaining tables. So here from B to C it is decreasing, it is also decreasing, and here increasing. Here also in the graph D also it is decreasing. So let us verify the remaining cases from the graph from this table with this graph C. Here f dash of A equal to 0. Here this slope is changing from at A. So there is a horizontal tangent at A and at B also. So this graph table 11 is matched with the graph C. And now let us verify this table 12. That is the f dash of A equal to 0, f dash of B equal to 0, and f dash of C equal to minus 5. F dash of A equal to 0 means a horizontal tangent at x equal to A. That may be top or bottom and local maximum and local minimum. Here there are local maximum and local minimum at A and B. That slope is decreasing at C. Here there is no horizontal tangent, and at B also there is no horizontal tangent. It is decreasing. So there is no possibility to the A. For this A, there is a horizontal tangent that is at local minimum at A, and this is the local maximum at B. So f dash of B equal to 0, f dash of A equal to 0, and this slope is decreasing. So this 12th table is matched with the graph B. Next, let us see this 13th table that at A does not exist. F dash of A does not exist. B equal to 0 and C equal to f dash of C equal to minus 2. It means that f dash of A does not exist means the graph at x equal to A has a sharp point. At A there is a sharp point or cusp or corner or vertical tangent. But there is a local maximum or a minimum local minimum at B. So this graph there is a sharp point at A and there is a local maximum at B, that is the f dash of B is 0 and this slope is decreasing. So this 13th table is matched with this graph D. And next let us see this 14th table that A does f dash of A does not exist and f dash of B does not exist and the slope at C is decreasing. So such graph is here there is a sharp there is a corner at A and here at corner B and this slope is decreasing at C. That is so that 14th table is matched with the graph A. That 11th table that local maximum or local minimum at AB and that slope is increasing at C. That is the C. That is the graph C, and this table is matched with this graph B, that is A B f dash of A equal to 0, that is a local minimum, here it is a local maximum and this slope is decreasing, that is f dash of C is minus 5 less than 0 and A does not exist. Here there is a sharp change, there is a corner at A, so that differentiation does not exist, and at B that f dash of A, f dash of B is 0. There is a horizontal tangent at B and this slope is decreasing at C, that is the minus 2. That 13th table is matched with the graph D. And this 14th table that A and B, there are corners at A and B and C, f dash of C is the negative value, that is it is at C decreasing, the slope is decreasing. These tables are matched with these graphs. Thank you for watching.